Thank you, Thomas. Yeah, before I get started, how many of you are using Docker at the minute? Can you put your hand up? Okay, so quite a few. How many of you are using Docker in production? Put your hand up if you've got it in production. Okay, that's not bad. That's quite a high ratio. You brave people. Just joking. So yeah, I'm going to be talking about Docker security. The boring bit about me, my official title is Chief Scientist at Container Solutions. But I wrote the book using Docker for O'Reilly Publishing. If you want a discount, you can use the code OFD on the O'Reilly site. There's also the free Docker Security mini book that you can get from O'Reilly, and that will cover a lot of what I'm going to talk about today. And I'm also at Adrian Mouat on Twitter. Okay, you can take a photo you want. Yeah, so I'm going to talk about Docker security. I'll start by talking about the benefits of security, why security is important. I'll then talk about some specific container attack vectors and security philosophy, what you should be thinking about when you're designing a secure system. We'll then have a short demo, so there's potential for things to go horribly wrong, like just now. And the final part of the talk, we'll be going through some specific tips and techniques for securing a Docker or microservice-based system. Okay. So one of the funny things about security is you don't really get anything for it, right? Nobody comes and gives you a gold star. If you have a secure system, sometimes it's no different from an insecure system. There's just a bunch of things that don't happen, right? So what doesn't happen is your site doesn't go down because there's some trivial DOS exploit. Your front page doesn't look like this because some script kiddies managed to break in and hack it. You don't start selling Viagra on the side, or at least I assume Tame Town Council in the UK didn't mean to start selling Viagra on the side. You don't lose your customers' credit card details. Clearly that's quite a bad one. Potentially put a company out of business. You definitely don't lose the records for like sensitive military intelligence personnel, and this included their families as well. So these were people that could be directly targeted by foreign governments or criminal elements. Okay, so that's why security is important. The next thing I want to talk about is what some important container attack vectors are. So things that are perhaps particularly important in a container or microservice setting. So the first one, and perhaps the most obvious one, is kernel attacks. So as you're probably aware, in a Docker-based system, the containers share the kernel with the host and the other containers that are running. And what that means is, if, for example, a kernel panic was to occur, it would take down not just that container, but the host and all the containers on it. So that's certainly something to bear in mind. Related to that, if one container starts using a lot more resources, for example, memory, it can potentially starve out other containers on the host and end up in a denial service. Container breakouts. People talk about this a lot. And this is just the worry that perhaps an attacker can break out of a container and onto the host machine itself or into other containers. Poisoned images. So this is just how do you know what's in your images you're running, especially images you download from Docker Hub. Are you sure they are what you think they are? Are you sure nobody's tampered with them in transit or at rest? And are you sure they're not running old or vulnerable versions of software? Secrets. So we've dealt with API passwords, database passwords, and API tokens for a long time, but it becomes a more acute problem with microservices when you've got all these containers coming up and going down and living for only a few seconds. So we have to be able to automate how we get our secrets into our containers, etc. Security paradigms. So what I want you to think about here is how should you think about security when you design the system? And there's two main paradigms I want you to bear in mind. The first one is defense in depth. So don't just rely on any one layer for security. Don't just rely on like a firewall to try to use a secure system. As well as a firewall, you need other levels, like encryption and monitoring and so on. And the analogy is with a castle where you don't just have the moat, you've got thick battlement walls, you've got defenders on the inside shooting at you, you've got portcullis, etc. And also there'll be multiple keeps inside, so there's a lot of levels to get to before you can get to the crown jewels, as it were. Then also the concept of least privilege. This is a very old paradigm, goes back to, I think, 70s by Jerome Salzer or someone. And it basically says that a process or a container should only have access to the data and resources that are essential to its function. Yeah, so for example, if your container doesn't need access to the database, it shouldn't be even on the same network necessarily as a database, and it certainly shouldn't be able to connect to it. There's a great talk by Nathan McCauley and Diogo Monica, who are security engineers at Docker, and they did a talk called Least Privileged Microservices at DockerCon last year, so I encourage you to look at that if you want to hear more about this. Oh, the demo. Do I have a, yeah. So I've only done this demo once or twice, so it could go horribly wrong. What I've done is I've run this container called NodeHack, which should give you a clue that perhaps things are going to go wrong. And all it is a simple service that allows me to upload a YAML file. So I'll show you an example. Oh, I'll show you the YAML file first. So we've got a simple YAML file like that. We're going to upload it. And all it does is highlight it. So very simple service. But it turns out the YAML library we're using is vulnerable. And so if we upload this YAML file, and you should already see there's something not quite right there, so some JavaScript code in there. If we upload this, what we get is this. So you can see something's not quite right. I'm going to go back to the main page. Our main page has been overwritten. So clearly, that's not a good situation to be in. And if this does ever happen to you, ideally you'll have, or you suspect your system's been compromised in some way, ideally you'll have like guidelines in place that you can refer back to and deal with situations like that. But first, what you want to do is to isolate the container and probably the host it's running on as well. And then you don't want to delete the container because you want to be able to like look at it and analyze it and figure out how it was hacked so you can prevent it in the future. And preferably, you don't even want to stop it because you may also want to look at the processes running inside, but you do need to isolate it immediately. And there's a few tools we can use. So the easiest way to isolate a container is, let's see if we can get this command correct. I think it's virg. Yeah. So that should disconnect the running container from the Docker network. So I'm assuming if I reload, yeah. So that's now inaccessible. And then it's still running, and also, even if it wasn't running, it was only stopped. I can still analyze the file system. So I can run docker diff. And that's telling me which files have changed from the image it was created on. So I can see that somebody's modified the index.html from just running docker diff. So there's already some tools that Docker gives you for helping to analyze attacks, etc. Okay, yeah. But, mitigation, that's it. There's also a bunch of ways that we can mitigate attacks like this using sort of simple Docker tools. And I quickly want to show you one of these called read-only. So if you run with a read-only flag, what happens is the container file system is set read-only. So we can see what happens if we rerun. So if we remove this container, and I'll rerun it, but with a read-only file system. Hopefully that's up again. Yep. So if I try and upload the same YAML file, I get an exception, and this on my front page is fine. And that's because Docker has stopped the JavaScript from being able to write the file, so it can't overwrite the main page. But it's very important to point out that that's not a solution. It's a mitigation. It's cut down what the attacker is able to do, but there's still a remote exploit there. You know, the attacker is still executing JavaScript on our computer. So the real solution is actually to remove the vulnerable YAML library that's running inside that container. And ideally, we'd be able to do this automatically, right? We could, in our build process, we could automatically scan our images for vulnerabilities such as this. And that's actually something that's really starting to take off in the Docker community. So there's a bunch of utilities now that do image scanning. There's Nautilus, which is Docker Inc. solution. They've talked about it a bit already, but it's not actually gone live for the public quite yet. I believe that's literally happening either this week or next week, though. There's other solutions. There's Claire from CoreOS, which is a free and open source solution. There's Pika from Skylock, which I played with a bit, and I've got an image in a minute. Twistlock, and there's also Atomic Scan from Red Hat. They all do roughly the same thing. So all they do is you give them your image, you upload it, or send it to the server, however, and it tells you what vulnerabilities it finds based on CVEs. So this is what I got when I uploaded that image. Interestingly, pretty much all of the vulnerabilities it finds are from the underlying Debian image. And this is like the latest Debian image in the Docker Hub. So apparently there's 113 high vulnerabilities in this case. And clearly that's not good. And you will find at the minute, if you run the Debian image, that they have those vulnerabilities. It's generally in things like libping is one of the big ones, and stuff that you possibly don't care about, but it's still not a great situation. But this isn't a fault of containers, right? Even if it's a Debian VM or an Ubuntu VM, you still have those same vulnerabilities. They're not patched by default at the minute. You can run like a more minimal thing, and we'll get to that in a minute. But at least it's highlighted the issue, and we can move on to fix things from there. And yeah, that's the next part of my talk. So just looking at some specific tips and techniques for securing systems. So a lot of people ask, are containers more secure than virtual machines? And it's an interesting debate to have, but it's also a bit of a false dichotomy, because you'll generally be using virtual machines and containers together. Most commonly, you'll be running your containers inside virtual machines. And what you can do is use virtual machines to segregate groups of containers at level of confidentiality. So you can do it on the level of users, but you can also do it on the level of systems. So you may have one group of containers that's doing your processing for credit card details, and the other set of containers that's handling the Node.js front end. And you can keep those in separate VMs. And that way, if an attacker breaks into the Node.js front end, they've still got a lot of work to do before they can get to the credit card processing containers. This is more something just to be aware of. If somebody has access to start Docker containers, they basically have root access on the host. Right? They could, for example, mount the root directory and play with things. So if you give somebody Docker access, you've given them root access to that machine. And because of that, you have to be very careful who you give access to. If you're using the remote API, make sure you control who has keys and only allow access via the internal networks or VPN. One of the interesting things about containers is that not everything is namespace, right? So one thing that's not namespace is time. So the time's the same in a container on the host. The kernel keyring isn't namespaced. And also users aren't quite namespaced at the minute. What that means is a UID in a container is usually the same as the UID in the host. So if I'm running this root in a container, and it's a container breakout, an attacker manages to break out the container, they will then be root on the host, which is clearly a bad situation. There is some work on addressing this at the Docker level. So there is like user namespace appeared in Docker 1.10, but there are some, and what that does is it automatically maps a root to a high-numbered user on the host. But there are some issues. For example, you can't use it with read-only file systems currently. You can't use it with --net equal to host or -- PID equal to host. And there's also some issues around volume. So you may have trouble using the user namespacing. And for that reason, it's very important to set users for your containers. So you will be, in your containers, you will set a user for the process to run as. This is very simple to do. You can just add, I actually took this example from the Redis Docker file. So you can see all we're doing is running a group add command in our Docker file that creates this user. And then we can use the user statement to switch that user. And that will take effect for all following lines in the Docker file and when you start the container. In some cases, you may want to do something as root when your container starts up. For example, change ownership permissions on files. And in that case, you'll want to create an entry point script that does what we need to do as root and then switches to the lesser privileged user. We've seen this already, but it is a very effective way of limiting the access that attackers have to a system, just setting a read-only file system. It's also very simple to do. In a lot of cases, applications won't be happy running read-only, right? Because they'll have one or two temporary files they want to write to. What you can do is you can explicitly mount those with the volume, so you sort of poke holes in the read-only file system. You can also use tempfs for such things, which is quite nice. And that's when the container comes down, that'll be wiped as well. So that can be quite an interesting technique. Very similarly, we can mount volumes as read-only, so that an attacker can't overwrite things. Drop capabilities. So Linux kernel defines a whole set of capabilities, like 30 or 40 different sets of capabilities, which map onto sets of system calls, kernel system calls. By default, a Docker container gets a reasonably large subset of these, but by no means all. You can get most of the capabilities by adding the -- privilege flag, or you can add and remove specific privileges by using cap drop and cap add. So in this first example, is this a pointer? Oh, it does. Oh, it doesn't work. So we can, in the first example, we're dropping the ability to set the SETUID bit on binaries and the SETGID bit on binaries. And in the second example, we're dropping all capabilities and just adding back the specific ones we need. Now, there's a couple of problems with this technique. The first one being, how do you know which capabilities your container needs? It's not really trivial. It's kind of a trial and experiment case at the minute. And the second one is there's some capabilities, I think it's sysadmin and netadmin, that are mapped to a whole bunch of kernel calls. So there's just too much in them. They're not granular enough. That's been addressed at the minute by setcomp. So there is setcomp support in newer Linux kernels and newer versions of Docker. But you'll need to be running like a Linux kernel greater than 4. And that allows you to specifically define which kernel calls are allowed to be made. CPU share. So I actually recommend by default you don't play with the CPU shares, because by default containers will get equal access to the CPU in event of contention. But in some cases you may want to say give one set of containers higher access than others. So like you might have more important batch processing or less important batch processing and more important interactive nodes or something. And what you can do then is pass a -c flag. But you have to remember that that Docker uses weightings here, and it's a relative weighting of 1024. So in this example, the first Docker container gets the default weighting of 1024, and the next two are given a weighting of 512. So what that means is the first container can access up to half the CPU, and the next two can access up to a quarter each. So you have to understand this default weighting of 1024 and how it's worked out, which perhaps isn't necessarily obvious. For example, if you do like -c1, thinking that'll set your CPU shares, what will actually happen in event of contention, if there's some like default containers around, they'll get all the CPU, and the -c1s will get none. So you have to be a bit careful about that. Memory limits. This is much more important because by default, a Docker container can use as much memory as it likes. But you can constrain the amount of memory by passing this -m, 512 megabytes in this case. There's also swap memory it gets by default. So by default, that will also give it 512 megabytes of swap memory for a total of a gigabyte. And you can control that separately. SETGID and SETUID binaries. So the default, like Debian and Ubuntu images, come with some binaries that run with elevated privileges. And the issue with these is, if an attacker gets into your system, they may be able to exploit one of these binaries to elevate the privileges. The thing is, you probably don't need them in your containers. So you can actually just take them out if you want. And if you run this find command in a container, in the default Debian container, you'll find a bunch of programs like this. And so, for example, who knows what chfn does? One or two people. So most of you don't even know what CHFN does, which means you can't really be using it. And it is arguably a security risk. I mean, it's an old and well-maintained program, so I'm assuming they figured it, it's not got any security risk, but potentially it could have. And you don't need it, so you may as well take it out. By the way, it stands for change full name, I believe, so it sets the thing in Etsy password that's used by finger and something. But it's simple to turn it off. We can just remove the SETUID bit with a command such as this. So we're doing chmod a-s on all the files with missions of plus 6,000. And you do that, and run the command again. There's no such binaries. Minimal images. So this largely comes back to that earlier picture we saw with Peaker, and the 113 was it, high vulnerabilities. You can use minimal images, like Alpine, that have much less in them. And if you have less software, there's just less things that can be exploited. And I actually ran the same thing with Alpine, and it found 0 vulnerabilities. And Peaker, is analyzing based on binary level, so it should find the same vulnerabilities if they are there. So basically, if you're running less software, you have less attack surface. Yeah, so look at the Alpine container, but you can go even further and just create a static binary that you run in the container and have no operating system at all. So you've just got the kernel and your binary. You can do it with Go. I guess you can also do it if you compile like a static C binary. And that obviously really cuts down your attack surface. It does mean that you may have more problems like debugging and stuff, because you won't be even able to get a bash shell, for example, in your container. Linux security modules. So the Linux kernel lets you plug in security modules. There's 2 famous ones, SELINUX and AppArmor. SELINUX was originally developed by NSA. It's now mainly a Red Hat product. It gives you this policy-based access control. There's this idea of mandatory access control that can't be changed as opposed to discretionary access control. And basically you apply labels and types, and it compares those to the labels and types that a process is allowed to access. And it covers file access, sockets, interfaces. It really is quite powerful, but it's quite detailed and can be a bit of a pain in the arse. It's hard to define your own policies. What you'd really like to be able to do is say, okay, I've got my web server policy for my Nginx containers. Go and run those containers with that policy. And you can do that, but I find it very hard to figure out exactly how to write the policy. And if you do use it, I say have to use device mapper there. I think that's not quite true anymore. I think you can use BetterFS, but the thing is, if you're using SELinux, you're basically running the Red Hat ecosystem most likely. So you're probably using device mapper and running on one of the Red Hat Rails or CentOS, for example, or Atomic. And the first thing you notice is that it's extra work to work with volumes. So for example, if you turn on SELinux, you just write a file and try to mount that as a volume, you're going to get permission denied. The reason you get permission denied is simply because the file is not labeled for being accessed by a container. We can change that fairly simply with the chcon command, but you kind of got to know that you've got to do something like that. I'm not being entirely fair here. You don't have to run the chcon command. You can just append a :0 now to the end of the -v argument, and that'll sort of run the chcon command in the background. But you still have to know how to do that. AppArmor, so that's very similar to SELinux, but a bit similar, possibly not as powerful. It's used by Debian and Ubuntu, and interestingly, you'll find it's on by default. So if you're running containers on top of Debian at the minute, you are using AppArmor. And again, it limits container access to files and kernel capabilities, and you can define your own policies. It's process-based and generally not as fine-grained as SELinux. It's also something to pain in the arse, but Jesse Frizzell, who was an engineer at Docker, now at Mesosphere, wrote a tool called Bane, and that's quite a nice little way of creating your own policies and just simplifies doing things. So check that out if you're interested. You can also run a security hardened kernel. So this is just a patch kernel of various security enhancements. The main one's GR security, and the main thing they have is something called PAX. And it's basically a set of memory level protection. So it'll do things like randomize things in memory, and it also, I think it maps certain areas of memory as read-only, and so it can't be executed, etc. There is a couple of issues. They tend to lag behind the latest kernel version, so you may have features that you want to use in the latest kernel version that aren't available in GR security, and there will also be a minor performance degradation. Verify images. So this comes back to the poisoned images idea. You want to be sure that the images that you're running are what you think they are, and you know where they come from. So if you get images from the Docker Hub at the minute, I would say try and use an official image if you can. And if you can't use an official image, make sure you only use an automated build. Don't go and use like some random image because you don't know what's in there, right? At least with an automated build, you can go and check a Docker file, and you can go and find the GitHub sources that it was built from and verify what's going on there. You can go even further and just download the source and build it yourself, and that gives you an extra level of security. To be sure what you're pulling is what you think it is, as in it hasn't been tampered with either at rest or in transit, you really want to either pull by digest, which is long like SHA hashes, or turn on Docker Content Trust. And that basically allows signing of images, etc. Auditing. So one of the nice things about Docker is this idea of immutable infrastructure. So generally with Docker, when you're running containers, you don't change those running containers, right? It's not like the old VM days when we had Puppet or Chef or something running and you updated the packages on the fly. Generally what you do with containers, or what you should be trying to do with containers, is when you need to update something, you change the Docker file, you update the image, you create a new container, and then you remove the old container. So that's the way you update things. You don't change things over time in a container. And one of the nice things about that is it means you can audit the offline images. And so once you've audited the offline images, you may audit one image and that'll cover like 100 containers. And you can then verify that those containers have not drifted from the image you're built from using tools like Docker Diff. And also, there's a bunch of scanning tools that I talked about earlier, like Pico and Scallop and Twister, that you can use to check your images for vulnerabilities. Obviously, if a new vulnerability is found, you have to scan not just the images in production before they're built and pushed, but the running images as well. Secrets. So this is quite an interesting topic. I've got this cat up here. So this cat, it's a cat in London, and its owner, he kept coming home with all these keys and things stuck to its magnetic collar. And at first, the owner felt quite sorry for it, with all these being dragged down by all these keys and stuff. But it turned out the cat was actually going and hunting out the neighbour's keys in the back garden and stuff intentionally and dragging them home, I guess, because they were shiny. And yeah, the neighbours got a little bit upset when their spare keys went missing. So there's several ways you can share secrets with containers. And as I said before, this is quite you have to really think about this in the microservice setup because it has to be automatic. And the most obvious way is just to write your secrets into the image, right? So you just put in your Docker file as a variable your API token or whatever. Hopefully, you're all thinking that's a very bad idea because it is. Anybody with access to the image is going to have access to your secrets. So don't do that. The next way, and this is quite popular, it's not terrible, but it's not my favorite way. And you can set environment variables for your secrets. So in this case, we can see we set an API token with an environment variable. And the reason a lot of people use this is because it's suggested by 12-factor apps. Who's aware of 12-factor apps? Oh, lots of you, cool, yeah. So I'm not knocking 12-factor apps at all. I really like that manifesto. But environment variables are probably better in VMs than they are in containers. And the reason is they can just be seen in too many places, right? So if you use --link to network containers, the link container gets access to all the variables in the other container. If you run docker inspect, you see the variables. If you run ps, you can see the variables. You can't change them once they're set, so it's not like you can just overwrite them. And so you get issues like, for example, if somebody's supporting you and they ask for the output of docker inspect or they ask for the output of env, and you send it to them without thinking, and suddenly you've like shared all your secrets or your API tokens with the support people by accident. So that's the reason I don't like environment variables. Yeah. So if you're not using environment variables, what can you do? Well, the only other easy option is to use volumes. So you put your secrets into the volume and mount that. You can't just mount the whole configuration file with a secret inside it, so rather than just the secret itself. And that's fairly simple, and it works. It's a little bit icky. I guess the main issue is that files have a tendency to get shared and checked into version control by accident. The future, I believe, belongs to secure key value stores. There's two main ones for these at the minute. So and this is just the same idea as like a Redis key value store, but it's specially set up to store sensitive information, such as API tokens and TLS certificates. And there's two main solutions, Vault and KeyWhiz. And they tend to have like a bunch of nice features, like leases, so you can say how long a secret's good for. They'll take care of storing things encrypted properly. And this is, I believe, where things are going, but there's still a bit of work to get there. And you're probably asking, well, how do you get access to the key value store? Doesn't that require a secret? And it kind of does, right? So you still need like to use an environment variable or something to get access to the key value store. But there's a few things you can do. You could use like a one-time password. So after your container accesses the key value store, the token that is used to access the key value store is invalidated and can't be used again. So even if it's given away or leaked or an attacker gets it, it's useless to them. Or I think Vault has this idea of app ID, whereby it generates a token based on some information it already has, like a MAC address. There's also a very nice idea of the volume plugins. So by using a volume plugin, if you use a volume plugin, you can set up the authentication to the key value store outside the container, and inside the container, you find a file that's mounted with all the secrets you have access to inside it. So I definitely think that's the future, but it's maybe not quite there yet. Yeah, in conclusion, the main point I want to make is that containers add security. They're just adding a level of isolation to existing systems. So if you're running with VMs at the minute, and you add in containers, you're not going to get less secure unless you do something very stupid, right? You only add in more tools and more isolation. And you have extra tools to work with for restricting attackers. If you are concerned about container security, do use them with VMs. And keep in mind principles of defense in depth and least privilege. And that's it. Thank you.
OK, so we have a couple of questions. So the first question, I guess you already just answered, really. Do you think that containers are inherently more insecure? Or do you think that the security issues are simply different and unfamiliar to people, and that's why that people have problems with it?
So yeah, they are different. I mean, people do sometimes compare like VM security and container security, and they make the point that a hypervisor is arguably more secure than like the kernel, but I'm not always convinced with that argument. But perhaps it is. But yeah, so if you're worried about it, use VMs and containers together. And they just do give you all these extra tools for security. So in the long run, I think it's good for security.
OK. Is there any situations where you wouldn't use containers because of a security risk?
Well, no. So what I would say is, if you do have a specific worry, you'll end up running your containers in VMs to address that risk.
So when you guys create containers, do you run? Do you have a continuous build system that validates them against one of these checking tools for
so I've been playing with that, but I don't think there's any. This is very new technology, and I mean, I ran a workshop yesterday, and I had troubles getting it working for that workshop. It just there is bleeding edge stuff. So I think you'll see that coming over the next year or so. At the minute, literally next week, Docker, I think next week or two, Docker will launch Nautilus, and that will automatically scan your images. I'm not sure you have to pay for it or whatever, or maybe it'll be for public images and not private images. I'm not sure.
Yeah, because I could imagine it even being part of the Docker CLI itself, right? Just checking it by default.
Yeah, I mean, what you really want is like Jenkins or whatever to check it and not allow you to push it if there's vulnerabilities.
Okay. Is there a way to, so you showed some security flags, right, that you want to use in general when you're doing different kinds of operations. Is there a way to enable these flags by default so you don't really have to consider these things when developing?
That's a good question, and the answer is not really at the minute. But I think that's something Docker are looking at. They have this idea of security profiles. So you'll have a profile that travels with your container, or your image rather, and it says which permissions it needs. So you run that, and it'll run with a read-only file system. It only needs a read-only file system, etc. So I think the future's bright, but no, at the minute you just need to know the different options.
Okay, thank you, Adrian.
Thank you.